See, if you look into the problem, what we have, they have given here. If you have x belongs to 0 to 1, they are asking us to prove that 1 by 1 plus x plus 2x by 1 plus x square plus this is 4x cubed by 1 plus x power of 4 plus on so on times up to infinity. We need to show that this is nothing but what, 1 minus x, 1 by 1 minus x, right? See, if you see this problem, you should not feel like it's difficulty. The thing is, what you need to apply the what I can say differentiation here. So let me show you how to apply. So if you look into the denominator, simply take it as a f of x. What is its derivative? That is 1. So we got f dash of x, right? Let us take f1. Okay, let us take f1, f1. Let us take, this is what, f2, f2 of x. What is its derivative? 2x, which is nothing but there in the power. So f2 of x. Is it okay? Yes. So what we will do, actually, I can rewrite this as, so let us rewrite it as, rewrite, or we can say the given series, which is in the form of, instead of rewriting, let me show you. The given series is in the form of, is in the form of, if you take denominator as f of x, its derivative will be there. Let us take f1, that is f1 dash of x. If you check about it, the denominator will be what, f2 f x. This is what was its derivative, that is f2 dash of x, right? Plus if you check about f3 of x, if its derivative will be what, 4x cube. So that is, let me write it as f dash of x. Is it okay? Plus on so on up to infinity. This is in the same way. Agree? So what we will do here, when we will be getting f dash of x by f of x, if you have something kind of a log. Okay, if you did not understand, don't worry. So now simply let us consider the following cases. Product of the terms. What is product of the terms? f1 of x, f2 of x, f3 of x. Okay, on so on up to infinity. Let us, instead of going up to infinity, let us take it about n terms. Is it okay? So that is f1 of x, right? For this, now what we will do, simply, what is f1 of x here? We will, the f1 of x is nothing but denominator. Let me show you in the denominator. Yes, oh sorry, yeah. So denominator will be 1 plus x. So simply let us take 1 plus x. What is f2 of x? 1 plus x square. F3 of x, 1 plus x power 4 on so on. This is what, multiples of 2. So simply nth term will be what, this is the first term, 2 power 1. Second term will be what, 2 square. I can actually write it as 1 plus x power 2 raised to the power n minus 1. Are you getting my point here? Yes. And what I will do, let us simply multiply 1 minus x. I'm just taking this extra term. I'll tell you why and how. Why? Because if you check into the first two terms, this is in the form of a plus b into a minus b. Is it okay? Is it okay? So what I will do, see, if you know one thing, if you ask me, ma'am, how I got 2 power of n minus 1, I'll give you a hint here. First term will be x power of 1 now. So the second term will be 2. Third term will be 4. Fourth term will be what? They will be giving you. So this is nothing but, they can give you 8. Agree? This is nothing but, I can write it as 2 power 0, 2 power 1, 2 square. Agree? This is 2 cube. On so on. This is the first term. This is second term. This is the third term. This is the fourth term. Means nth term will be 2 power, what you will be getting? N minus 1, because this is our first term. Okay, this is our second term. Second means 2 minus 1. This is our third term. That is how I got 2 power of n minus 1. Is it okay? Yes. So now let us move on. Why I have taken extra 1 minus x is, if you check this, this is in which form? This is in the form of a plus b times a minus b. What is the formula for a plus b into a minus b? A square minus b square. I will be applying the same formula here. This is a square minus b square into, second term will be as it is. Agree? Third term will be as it is. I will be writing on so on up to 1 plus x raised to the power 2 power of n minus 1. Is it okay? Yeah. So if you check this, this is 1 minus, again the denominator. This is in the form of what? Again this is in the form of a plus b and a minus b. So what we can see, again a square minus b square. So same thing I will be applying here, which is nothing but 1 minus x square the whole square. Okay, into, this is 1 plus x power 4 plus on, or not plus, it should be into, everything I have taken it in terms of what, product of the terms. Is it okay? This is nothing but 1 plus x raised to the power 2n minus 1. Agree? So this is nothing but 1 minus x to the power 4 into, this is 1 plus x raised to the power 4. Again I'll be getting the same formula here. Is it okay? Yeah. So what I'll be getting 1 x power of 2 power n minus 1. So this is nothing but what I'll be getting the next term, which is what x power and so on. Let me show you. So finally what I'll be getting here, okay, this is nothing but, if you want this I can simply get, let me show you, a square minus b square 1 raised to the power 4 to the 8, agree, on so on. Last term will be 1 plus x power 2n power minus 1. Is it okay? Yeah. If you check this clearly, what will be the last term you'll be getting here? Simply 1 minus 2 power n. This will be minus 1. Okay. Into this is 1 plus 2 raised to the power, okay, not 2. This is x raised to the power 2. I have missed x here. This is x raised to the power 2 power n minus 1. Here, x raised to the power 2 power n. This is minus 1. Again, this is in the form of a square minus b square. So this is nothing but a square minus b square. What is a minus b square? I can simply note in such a way that, okay, this is a n must be into the power here. I have written down, maybe that was a mistake. This this is a nth term, which is n minus 1. Okay, not here. This is in the raised to the power. Okay, n minus 1, n minus 1 here, n minus 1 here, n minus 1 here, n minus 1. So this is x raised to the power 2 power of n minus 1 the whole square. Is it okay? If you know this formula, we know a power of m whole power of n is nothing but a power of m into n. So let us apply this one. So what we will be getting here, this is nothing but 1 minus 2 power n minus 1 times 2. Okay. A power of m into a power of n. What is the formula? A power m plus n. Is it okay? So I'll be applying the same formula. 1 minus x raised to the power 2 power of n minus 1. This is plus 1. Nothing power is there, means 1. So simply I can remove plus 1 minus 1. So what I'll be getting? 1 minus x raised to the power 2 power of n. Is it okay? What is this? So what we have taken all the product of the terms. Let me show you. I have taken, just a second, 1 minus x into 1 plus x into 1 plus x square into 1 plus x power 4, agree, plus on so on up to n terms. 1 plus x raised to the power 2 power n minus 1 terms I have taken is equals to 1 minus x raised to the power 2 power of n. But if you look into the problem, they are asking about infinite terms. Infinite terms means what should we do? So we need to check if this problem, if n is tending to infinity, what will happen to this value, agree. So let me solve this for further. If n tends to infinity, we can say that x raised to the power 2 power of n, this will tends to 0, because check into the question here what they said, x lies between 0 and 1. So if we have x belongs to 0 and 1, agree, obviously x to the power of infinity will be how much? That is 0. You need to note it down. This is a rule or the formula we'll be using here. Is it okay? Yes. So this will be tends to what? 0, agree. So let me write it down here. So simply what we can say, if I take 1 minus x into 1 plus x into 1 plus x square into 1 plus x power 4 on so on up to infinity, agree. If I goes to infinity, what it will be? X goes to infinity. So I can conclude that this is nothing but what? Simply 1 alone. Is it okay? Let me write it down. This continuation part here. Okay. If you have 1 minus x, 1 plus x, is it okay? Yeah. So this will be what? This will goes to, okay, let me substitute here. This is nothing but 0, because I got this as a 0. This is 1 minus 0. Are you getting my point here? I have applied simply n tends to infinity. Is it okay? Nothing else. So finally I got it as 1 minus x times 1 plus x times 1 plus x square 1 plus x power 4 on so on up to infinite times. I got it as a 1. So what should we do? Simply take log on the both the sides. We are having product of the terms, right? If I apply log here, what I'll be getting? Log of 1 minus x, 1 plus x, 1 plus x square, 1 plus x power 4, on so on up to infinity, must be equals to log 1. Remember, we have to note it down. Log AB. What is the formula for log AB? Log A plus log B. And what is the log 1? We know that log 1 will be 0. I'll be applying same formula in this case. So this is nothing but log of 1 minus x plus log of 1 plus x plus log of 1 plus x square plus log of 1 plus x power 4. Agree? plus on so on up to infinity. This is log 1 value will be 0. Now what should we do? Let us differentiate. Why? Because our question is different, right? If I differentiate this question, this function with respect to x, log x derivative. Okay, let me write that also. We already know that log x derivative will be what? 1 by x. Okay. So log x derivative will be 1 by 1 minus x, and x derivative will be minus 1. This is 1 by 1 plus x. X derivative will be 1. This is 1 by 1 plus x square, and x square derivative will be what? 2x. Plus log x derivative will be 1 by 1 plus x power 4. X power 4 derivative will be what? 4x cube. Plus on so on up to infinite terms must be equals to what? Constant terms derivative will be what? Again 0. Any doubts in this? If I check this clearly, minus 1 by 1 minus x plus 1 by 1 plus x plus 2x. This is the reason I have taken product of the f1, f2, f3. Is it okay? Plus 4x cube by 1 plus x power 4 plus on so on up to infinity is equal to 0. If I send this extra term is there, try to send it to the right side. What I'll be getting? 1 by 1 plus x plus 2x by 1 plus x square plus 4x cube by 1 plus x power 4 plus on so on up to infinity. What we'll be getting here? Negative term. If it goes to the right side, it will be positive 1 minus x. So what they're telling, they're asking us to prove this one. So this is how I'll be proving. I think this problem is little bit lengthy as well as confusing. You just note it down. If you have any doubts or if you did not understand any line in any step, you can mention in the comment section. I'll try to make sure that you will understand rest of the things. Is it okay, right? Yes. Only thing is, remember this is very important. If n is tending to infinity up to n terms, this will be what? This whole function will be tends to 0. That is what you need to remember. That is how I got 1 minus 0 here. Rest everything will be easy only. Is it okay? Yes. Okay, then thank you.